Okay, question number 48 from the polar conics worksheet. Okay, find the polar intersections of the hyperbola. Well, it's nice they told us a hyperbola with an eccentricity of 3/2 and a directrix of negative 8/3. Okay, so that's the first one, and the other one's going to be the line 2/3 x plus 1. Okay, so that's great. That's nice because at least we have that equation. All right, for this we'll put it into our equation. All right, E times D. Right, and I guess it didn't say it in there. The implication is that it has the focus at the origin there. And so we're going to multiply those two together. All right, D being 8/3, not negative 8/3, but 8/3, and E being 3/2. So we'll get for that we'll get 4, and then 1 minus E. All right, we're going to use cosine theta here. All right, again we're using cosine because the directrix is vertical, and it's negative because the directrix is to the left. Better form of this would be 8/2 minus 3 cosine theta. So we have our equation there. Alright, so we also have our line over here for ourselves. And so I need to change this to polar form. So I remember that that y is r sine theta in polar form from what we did earlier here with polar coordinates, and x is r cosine theta. Oops. Okay, if I scale everything by 3 just so I don't have any fractions. I get this. Okay, now I'm going to solve this one for r. The reason I'm solving for r is because this one over here is solved for r, and so I'll move this over and factor out the r. Okay, so I get something like that. Okay, so I can set these two equal to each other now. Okay, now this one's not going to be a piece of cake to solve because there's got two different trig functions in it, but we'll do the best we can. All right, let's get rid of the fraction first and then combine some like terms here. So we'll get 24 sines of theta minus 16 cosines of theta equaling 6 minus 9 cosines of theta. Okay, just double checking my work. Yep, okay. All right, moving and then I'm going to get I'm going to keep the sine over on this side and move the cosine to the other side. So I'm going to add that, so that will give me 7 cosines of theta. The reason I do that is now that when I square it, I'll be able to get rid of one of the trig functions. All right, for myself, that'd be nice if that could reduce, but it can't. So I'll just square it. 36 plus 84 cosines of theta. All right, and then the last one's going to be okay, 49. Okay, so I can then replace this right here with 1 minus cosine squared, and that's going to give me 576 minus 576 cosine squareds of theta equals 36 plus 84 cosine of theta plus 49 cosine squareds of theta. Let's see, how about I move everything over here just so I can keep my cosine squared term positive. So I'll move that over, and I'm going to get 625 cosine squareds, right, plus 84 cosine of theta, and then I'll subtract 576 from both sides, get negative 540. Okay. Again, it'd be really nice if this reduced, but it's not going to be. This is only factors of 5, right? And there's no factors in of the other two as 5. So we're just going to have to go to quad formula there. All right, so negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's going to be 1250. Okay. And at this point, let's see, does it say to round? It doesn't say to round. How about we round though, because that's just a sheer sheer brutality in there. All right, so we'll get our two answers as cosine equaling 0.8647 or cosine equaling negative 0.9991. Okay, and now we can find our angles off of that. Right, we can get the angle for this as being 30.147. Right, and then from that you can then use this relationship, right? You know, the relationship between right here. Here we go. Plug it right in there, and we get our R for that one as negative 13.46. And then we do the same thing for this angle, right? So the angle 182.374. All right, and then the radius is going to be 1.601 degrees. Okay. If we graphed it, we can then, it says sketch it to validate your answer. So the directrix here is 1. Okay. All right, for ourselves. Okay. For this graph right here, if we want to find the vertices, we can plug in 0. Right. So if we plug in 0, that'll give us 8 over 2 minus 1. So so that's going to be negative 8. So if the angle is 0, we go to the negative 8. So remember, that's 8/3. So it's almost 3. 3, 4, 5, 6, 7, 8. Okay. If I plug in pi, right, this is going to be negative 1, which is going to give me 8/5. Right, 8/5 being right here. Okay. So my graph's going to look something like this. Okay. We can see that that's, you know, from here, that's 8/5. So from here, it's 8/5. So it's going to be something like this. And the line y equals 2x plus 1. There's plus 1, right? And then slope is going to be something like this. Okay, for myself. Okay, so if I look at my answers, the angle of 30.1, right? The angle of 30.14 means you're going to go back negative 13. So that point I could label as, you know, with this information, or I could do it as 210.147 with a radius of 13.46. Oops. Right, I could do that. And then this one with an angle of 182 degrees and a radius of 1.60. Oh, actually, you know, I guess I must have put this too high. I must have dropped down below, and maybe my slope was off. All right, because that angle would be more 182, be down like here. So it must just have been my slope being off a little bit there to have that point incorrect. Okay, so hopefully that makes sense. Let me know if you still have questions.